We've developed a method to initiate polymerization using dynamic sulfur bonds in polysulfur divinylbenzene at 90 degrees Celsius without the need for solvents. This is substantially lower than traditional methods, which require temperatures above 160 degrees Celsius. Lowering the polymerization temperature broadens the range of monomers that can be incorporated into polysulfides by inverse vulcanization. This expands possible materials' properties and possible applications.
Inverse vulcanization has produced polysulfides that have been used in lithium sulfide batteries, as infrared transparent lenses, as mercury and oil sorbents, among other applications. This method would enable the development of new materials and likely additional applications.
One of the key benefits of this method is the relative ease of the synthesis. This video provides the opportunity to demonstrate how the reaction progresses over time, as well as showing how much the polymers can vary based on the sulfur content and the ratio of the monomers present.
To prepare poly-S-Divinylbenzene, combine elemental sulfur and divinylbenzene at the desired weight ratio in a 1-dram vial equipped with a magnetic stir bar. Place the vial in an oil bath at 185 degrees Celsius for 30 minutes. After the reaction is complete, remove the vial from the oil bath and immediately quench by placing the vial in liquid nitrogen. Then break open the vial to remove the polymer, and repeat this step for each polymer prepared. To synthesize terpolymers, first crush the polyester.